Alright, almost done. We need to multiply radicals with different indices. So cube roots and fourth roots we want to multiply together, or cube roots and square roots we want to multiply together. How they're sitting right now, we cannot combine them. I can't just multiply the stuff on the inside. So what I need to do is change them back into their fraction form. Because fraction form, I can use the exponent rules that we learned way at the beginning of the year. So the cube root of 5, remember, is the same thing as 5 to the 1/3 power. And I want to multiply that by the fourth root of 5, which is 5 to the 1/4 power. And then remember what our exponent rules say, that if our bases are the same, they're both 5s, we can add the exponents. So let's have a little side problem of adding 1/3 and 1/4. Got to find an LCD. So 12 is the smallest number that they both fit into. To make 1/3 into 12, I got to multiply it by 4 on the top and the bottom. And then to make 4 into 12, I got to multiply by 3 on top and the bottom. And then we can combine to get 7/12. So back to this problem. We really have 5 to the 7/12. And because we started with radicals, we want to end with radicals. So let's not leave it as this fraction. Let's turn it into something that we know with a radical. So remember, the number on the bottom is what your index is, and the number on the top is just like your normal plain old exponent. So this simplifies to the 12th root of 5 to the 7th. You could figure out what 5 to the 7th is, but because it's such an enormous number, don't even bother typing it into your calculator. It's 78,125. But we can just leave it like this. Let's do the next one. Alright, so this next problem is kind of strange. In order to use the exponent rule, like we did in the last one, we would want the same base. And when we turn these into radicals, we get 7 to the 1/3 power times 2 to the 1/2 power. And our bases aren't the same. So we're going to kind of go backwards. We're going to make them have the same denominator in their fractions, and then we can combine them. So if we want to turn both 1/3 and 1/2 into something with the same denominator, we're going to turn them both into 6. So the first one's going to be 2/6 and then 3/6. So 7 to the 1/3 could also be 7 to the 2/6. And 2 to the 1/2 could be 2 to the 3/6. Now because both of these are divided by 6, that means both of them have the 6th root. Or we could write this as 7 squared times 2 cubed, all to the 1/6 power. And we know that 1/6 is what our index is. So we have the 6th root of 7 squared times 2 cubed. Now because this is very strange, let's simplify this. The 6th root, 7 squared is 49. 2 cubed is 8. And if we multiply those two things together, we end up with 392. So this whole thing simplifies to the 6th root of 392. And you can check these, because if you multiply what we started with in your calculator and what we ended up with in your calculator, you should end up with the same messy decimal. And that is all of 6.5.